Hello, good morning. Yeah, today I'm going to go over a couple of previous homework problems, and then we talk about numbers here. So so this is one of of the exercise. I know you did it. Some of you confused. To do this type of problems, is you should draw a table. Okay, so that's usually I do, draw a table. Okay, and then this side for the girls, this side for the boys, and here they are brain range. This is a by range. Okay, and then you figure out all the numbers and try to, okay, so there are 106 grade girls, right, and who buy lunch, so 100, right? Then 70 boys who bring lunch, so you put 70. And then there are 160 boys in the sixth grade, so 160 boys, right? So then actually this would be 90 boys, right? 90 boys who buy the lunch. Total 160, right? Total, right? Then 160 students who bring the lunch. Total 160. So already you know 70 boys who, right? 70 boys bring the lunch. So there should be 90, right? 90 girls who bring the lunch. That's it. So use the whole picture now, it's clear. So this side is 190, right? Total together, and the 350. Okay, so then it's very clear. Yeah, I do have how do you get in? I do have a password to this class. Okay. All right. So now let's take a look at the next problem. Okay. Let's take a look at the next problem. For a certain sequence of numbers, the sum of the first n numbers in the sequence is given by the formula. Right? This is then you want to find out what is the tenth number in the sequence, or in general, what is the nth number in the sequence. So here's we call it partial sum. We have a sequence, right? So you have a sequence A1, A2, A3, AN, and so on, right? So add them together. This is called the sum of the first n term, right? So based on this formula, and you see that if n minus 1, the sum of n minus 1 terms, you get n minus 1, right? Here's n minus 1. So you see the difference. So the nth term here can be also expressed in the form, the difference of those two, right? So the difference of those two. So if you know the formula for the sum of the first n terms in general, then you can also figure out the nth term, okay, using this identity. So we can even get a general formula. We know that what we are given. We are given Sn, which is n cubed plus 4n. So using this formula, you also can figure out S minus n minus 1, which is n minus 1 cubed plus 4n minus 1. So I can figure out the nth term. Nth term is the difference of, that's too bad. Yeah, the difference of those terms. Those two terms difference, okay? Okay, so even I can get a general form, not as a 10th term. So minus n minus 1 cube, and then minus 4 n minus 1. So after you simplify it, you can, well, you can get the general term. Let's see what do we get here. N cube plus 4n, and here I have n cube minus 3n squared, plus 3n minus 1, and minus 4n plus 4. Okay, so n squared is cancelled out, 4n cancelled out. So what I get is I have a 3n squared minus 3n plus 1 and plus 4, which is plus 5. So that is actually the formula for the nth term. Okay, then when n equals 10, you can get an answer. Okay, when n equals 10, you get an answer. Okay. So I'm not going to take care of that part. So you can get what is 8 tenths is going to be 3 times 10 squared minus 3 times 10 plus 5. Okay, so that's the number. Okay. All right, so the next one, I only copied it because the problem is too complicated. I don't want to waste time to write. Okay, so this is if the numerator of fraction is increased by 6, the value of the fraction will increase by 1. If the denominator of the original fraction, not the resulting fraction, okay, is increased by 36, then the value of the original fraction will be decreased by 1. So what is the original fraction? Well, you just write down the fraction, right? The original fraction will be denoted by m over n. Okay, so you translate each statement into equation. So the first equation we get, the numerator is increased by 6. Okay, so increased by 6, then the fraction is will be increased by 1. So that's increased. So that's the original fraction, m over n. That's the first equation you get, right? So numerator increased by 6 to 86. Then the value of the new fraction will increase by 1. So it's going to be the original fraction plus 1. Then the denominator of the original fraction is increased by 36. Then the value will decrease, of course, right? So decreased by 1. Okay, so you got two equations. The problem is how do you solve it, right? Well, that's the first equation, second equation, and to solve them, what is a simple way to do? Okay. I think the first equation is relatively simple, so we find a relationship. So we multiply the first equation times n. So you get m plus 6 equals m plus n, right? Clear? Right? Yeah, m over 6, right? So that means, yeah, so that implies already n is going to be 6. Yeah, n must be 6. So using this 6, and plug it into the second equation, right? Then you get m over, right? 6 plus 6 is 40, 36, 42, m, right? And that's 6 minus 1. And here you can, here you can multiply by 42, right? Right? So m equals 42, it's a 7m minus 42, okay? So then 6m equals 42, so that means m equals 7. So the original number is going to be 7 over 6. The answer is 7 over 6. Okay, so all I have to do is just translate each statement into an equation, and you have two unknowns, m over n, m and n. Then you should have two equations in order to determine the values of the numerator and denominator. And the next step is what is the best way to solve, right? I find out the second equation is more complicated if you want to get rid of the denominators. The first equation has a common denominator n. That's why I multiply by n. That's it. All right. Okay. So speaking of sequences, do you know what is the arithmetic sequence, right? So we have yeah. So so here's a question: the arithmetic sequence. I don't call it here. Let me check. I call the progression 5, 8, 2, 5, 8. Come on. Yeah, let me write down those two sequences. First one is 2, 5, 8, 11. Like that. Another one, 3, 10, 17, 24. So these two sequences have some common values. Okay? What is the largest value less than 500 that they have in common? So you're trying to find the sum of them. What is the largest value? Okay? Less than 500 that they are in common. Okay. So we want to find out the largest value, which is less than 500, and in both sequences. Okay. Now, can you figure it out quickly? Again, you have to get an equation. No equation, you cannot solve the problem. Okay. The first sequence, okay, is increased by 3. So every time, so it's begins the first term plus 3p. Okay, when p is from 0, 1, all the way, right? And the second sequence is 3 plus 7, q. Q is also start from 0, 1, 2. Okay. They're in common means for some p and some q, they should be equal, right? Then both also have to say less than 500, right? Now, yeah, it's harder to determine the value of p and q at this moment because by the divisibility. Okay, the reason is 7q minus 2 should be divisible by 3, something like that. Maybe it's not a, it's not easy to check to see that. Okay, so what I'm trying to do here is you look at the largest possible value for this arithmetic sequence, which is less than 500. So it's 497. Okay, 497, and that is the largest number. Okay, which is less than 500. Okay, and yeah, if we add 3 to 500, is also can be written in the form 2 plus 3p. So it's less than 500. So then 494. We hope, you write a few of them. Okay. And then, yeah, 482, 479, and 476, 47. Okay. This is going to be, yeah, minus 3. Yeah, that's good. Okay, so 3 plus 7q. The largest number less than 500 is 493. Now, how can I get this one? Then you just minus 7, right? 486, 479, okay? And then 472. Okay, so then you look at, right? I think we still find that why not working? This is a 479 sounds like a working. Right. Yeah. Now, so how do you find the largest number, which is in this form? Well, you just yeah. How do I get this number? Then you subtract, right? Subtracting 7 each time. So the way we do is I trying to solve this inequality. It's less than 500. Then 7q is less than 500 minus, right? 500 minus 3. Yeah, that's it. 497. Then I divide by q, divide by 7. Okay, so it's 71. So that's why I choose 70. So 3 plus 7 times 70 is the largest possible number you're going to get. 3 plus 7 times 70, it's going to be 493. So that's the number I begin with. And then you just decrease. Okay. I think 479, it should be nice. Okay. Right? Because when you look at those numbers and you see you see that that's one in common, 479. If our computation is correct. Okay. I think it's correct, yeah. Yeah, you're looking for the largest number values, less than 500, in common. You have to begin with the largest number in the sequence. Right. So our next problem, yeah, we know that A and B are integers. All right. We also know that A is greater than 1, less than equal to 10. B is greater than 1, less than equal to 36. Okay. solve this solve this one, which should be integer for A and B. Okay, so clear. We're trying to find the all the pairs of numbers such that this square root of A plus square root of B is going to be integer. Okay. Well, for example, when A equals 10, right? B equals 36. And this is indeed an integer, like 10 plus 6, and it's a square root of 16, which is 4. I just give example, right? So questions are, what are the other possible solutions so that this one become an integer? How do you solve it? So my hint is, what are the largest possible value for this? The largest possible value for this is going to be, A is the largest possible value is 10, B is a 36, which is a 4, right? And then the smallest possible value is going to be square root of 1 plus square root 1, which is square root 2. Okay. So this one is an integer. There are not many values for this one, right? It is only equal to 2, 3, and 4. So clearly A plus square B is the only possible values, so-called integer is, right, among those 3 possible values. Okay, right? Because it can be integer. So what kind of integer? It's not a very arbitrary. So it can be only three possible values. So you continue, okay? I hope we can find all of them. Okay, so case 1, if square root A plus square root B equals 2, and A plus square root B equals 4, right? And in this case, I think it's easy to get. You can let A to be, you let A to be 1, right? So A, B, if A is 1, right? Then square root of B is going to be 3, so B is going to be 9. If A is 2, right? And then square root of B is going to be 2, so it's going to be 4. If A is 3, and the square root of B is going to be 1. That's it, right? Because B is integer, greater than or equal to 1. So that's it. So the second one, when a plus square b equals 3, it's the same idea, okay? So a plus square b equals 9, okay? In that case, using the same idea, you can let a to be 1, right? If a to be 1, it's not good. If a could be if a is 1, the reason is that if a is 1, 1 plus square b is going to be 9, right? So square b is going to be 8. This never happens. So square b must be less than or equal to 6. Okay, so you have to start with 3. Okay, when the 3, then it's 36, and then when it's 4, it's 25. Yeah, then when it's 5 and 16, when it's 6, it's 9, when it's 7, you get 4, when it's 8, you get 1. Okay, just same idea. It's just so so the a starts from 3, 4 all the way to all the way to 8. Okay, then you get the solutions for b. And the third one is a square a plus square b equals 4. Okay, when it equals 4, there's only one solution here because a plus square b equals 16. Okay, and that's right. So the only possible solution here is a equals 10 because otherwise b is a 36. Okay. Yeah, b is 36. Okay, that's easy to see. So we solve this problem. Okay, we find all the solutions. Okay, our second question is this is interesting. Positive, you probably never see the problem like that. Positive x satisfy this equation, but with infinite many terms. Right, was satisfying the equation with infinite many terms. Okay, radicals. Yeah, radicals. Okay, now here's x plus square x plus square x, and this can be 5. Now what is x? Okay. Well, now how do we define an expression with infinite many radicals? This is defined to be the limit. Okay, we have to understand the limit, the concept. So with finite many terms, like this is the first one, right? Yeah. Yeah, the above sentence, above one means that first of all you begin with one radical, then 2 radical. Okay, clear, right? And 3 radicals. Okay, and just keep it going. So n radical. So you have n radicals. Okay, now do you think this is a sequence that's increasing? I think so. So this is a less than, and this will be less than that, it will be less than this. So you have a sequence of, for fixed x, you have a sequence of numbers on this line, and this may be square x, maybe this will be square x plus square x, and just keep it going. But their increase is very slow. The limited case is 5. Okay, the limited case is 5. Okay, so the above equation tells you the limit is going to be 5. Okay, so this is a approaches 5. And therefore, we just say they're equal. You know, if you put the infinite many term, infinite many radicals. Okay, this is the ends. This is the expression with n radicals. Okay, now if infinite radicals means the limited case, that's equal to 5. Okay, clear. It's increasing sequence. Okay, I just explained to you the meaning of this. Okay. The above equation means the limit is going to be the limit is equal to 5. Okay, the equation means. Okay, now how do you find x? Wow. Okay, I think in the limit case, infinity minus 1 stay infinite. Okay, so it's no difference. Okay, this is important fact. So that means if we look at this part, okay, do you think this part is the same as the whole expression? The answer is yes. Okay, it has infinite many, but just less than 1. But if it has still have infinite many radicals, so then you can just replace by 5. Okay, replaced by, oops. Right. Yeah, replaced by 5. Then you solve the problem immediately. Right? Right, so you squared both sides, so x plus 5 equals 25. So x is going to be 29. Yeah, x is 20. Right. Similar ideas used in the opposite way. So, for example, what is the value? Actually, we will try to find out what is the value of this expression. Okay, I change x to let's say just to 5. Was the infinite many radicals? Okay, it's the same idea. Okay, to solve this problem, you let x to be that, right? Okay, then this part is the same as the original one, right? So then x is going to be square 5 plus x. Okay, because this part can be replaced by x by the whole part. Okay, although this is like inside, it looks like but it's the same copy. If you so no difference, infinity minus 1 and infinity, right? So this part is repeated, the same with infinite many radicals, and so then you square both sides. Then you get a quadratic equation, right? So x squared minus x minus 5 equals 0. And then you solve it. Okay, solve this quadratic equation. And in general, you get radicals in this case. It's going to be negative b plus I think, yeah, b squared minus 4ac. So it's 21. So 1 plus minus square root 21 divided by 2. So the answer is, it should be positive. The answer is 1 plus square root 21 over 2. So this so many, yeah, this is going to be 1 plus square root 21 over 2. Okay, it's an irrational number. All right, good. So our next problem I wanted to do that. Okay, so A, B are, okay, again, A, B are integers. Okay, so A is greater than B, greater than or equal to 0, so B could be 0. What is the smallest possible value of the following sum? Okay, wow. What is the smallest possible sum? Okay, so A plus B over A minus B plus A minus B over A plus B. Okay, so A is greater than B, so this is always positive. It's pretty complicated. But you notice that they are reciprocal to each other, right? So please work on this first. Now, you may guess and try and find a small number, but you have to prove it. Now, why your answer is the smallest, smallest value of the sum? Well, I probably just combine them into two terms, into one. So A minus B, A plus B, and here A plus B squared, and A minus B squared. Let's see what we can get. The denominator is A squared minus B squared. The numerator is A squared plus B squared plus 2AB plus A squared plus B squared minus 2AB. So what I get here, I get twice A squared plus B squared. So denominator is A squared minus B squared. And now remember B, A is greater than B, right? A is greater than B. That's all we know. Okay, A is greater than B. Are they integers? Yeah, they're integers also, right? Now clearly, from this expression, do you think the numerator A squared plus B squared is greater than A squared minus B squared? Yes. So you should greater than 2 times 1, right? Right? Because A squared plus B squared is greater than or equal to A squared minus B squared, right? So that's why numerator is greater than denominator. That's why greater than or equal 1. Now, do you think it's possible they're equal? The answer is yes. This is when equal to when numerator equal denominator. I think when b squared equals 0, right? If b squared equals 0, that's equal. So the smallest possible value you're going to get is 2, because it can be reached, right? And when it be reached, when b equals 2, when b equals 0, right? That's it. If you just go ahead to simplify, and you will see it immediately, right? Okay, it's not that complicated, right? Yeah. If you just sit there without doing anything, then say, oh, how can I do it? Then it's harder to tell. So first of all, you see it's greater than or equal to, so it's possible, smallest possible value is 2, but you have to make sure it can be reached. Okay. Right. Our next problem is also equation the system equation. So it's going to be 3 to the x plus 1 equals 81. And here 81 to the power x minus 1 equals 3. Please find the x and y. Okay, I want you to do that. This is not complicated problems. Okay, please work on this. Okay, great. I found out, well, yeah, use a proper fraction should be better, Grant. Yes. Okay. So the idea is very simple, right? 81, it's going to be, 81 is going to be, right? It's going to be 3 to the fourth power, right? Yeah, 3 to the fourth power. And so you can, from left hand side, x plus y equals 4. Now this side is going to be 3 to the fourth power, x minus 1 equals 3. So it's 4 times x minus y equals 1. Okay, combine them. Okay, so using solve these two equations, linear equations, then you get x equals, I'm not going to repeat it, and the y is going to be 15 over 8. Okay, that's great. Okay, so those are the equations. Yeah, we have to solve. Well, there's another equation. We probably have to solve it. There's lots of unknowns. Okay. Let's see. I'm not going to give you this problem. All right, okay, so we're trying to figure it out. So we are given here. Okay, so it's a six, the sum of a 6 digits. Okay, we have a 6-digit numbers. Okay, so 6-digit number we don't know, and the 3 and the 1. Okay, so it's This is a not 6-digit number. Okay, so how many digits? 1, 2, 3, 4, 5, 6. This is 6-digit number. Minus 7, 6. Okay, so this is a 5-digit number. Okay, then you have another 5-digit. Okay, so we know this is a A, B, and the C, and the D, and the E, and the F. Okay, and we're trying to find out A, B, C, D, E, and F. So there's so many unknown numbers here. Okay. All right. So to solve, you're trying to find those are the digits. Okay. This can be any of this. Yeah. Any of this digit from 0 to 9. And this is the equation. We hope, sometimes it's written in the form like that for the plan. And then it'll be 7, 6, this is unknown, and 3 and 5, and then at the end you have, we don't know this number, right? And the 8 and the 2, right? And the 9, and this is the number unknown. Okay, so we're trying to figure out all those digits in the boxes. Okay. Now, how to start with? Now you can have equations. I think, we want to find out all the possible digits. Okay. We want to find out at least we want to find the original question says find the sum of those digits. Now sometimes maybe you have multiple solutions, but sum does not change. Okay. All right. So to solve this problem, I prefer to just write down the equation on A, B, C, D. Okay, and then trying to, for the first one is you have a 1. How many zeros here do you have? This is 6. 5 zeros. Okay, and 8. Okay, plus 60,000 plus 1,000 B plus 300 plus 10C plus 1. Okay. Then maybe I move the other term to the right hand side. Then I get 7 35 plus I add them together. So those two together. So this is on the right hand side. I get okay. So those are this translate this equation into this equation. Then you try to simplify it. Okay, you try to simplify it. Okay. So you put all the integers together. This is already no integer, right? No, not this one. This one. To see if we can end the 35, right? Okay, and I'll keep F on the right hand side. I got 25014, and then I get 508 plus 1000D plus 10C minus 100D, I think, and minus 10,000E. Okay, so this is a kind of equation, and A, B, C, D, E are all digits. So look at this identity. You will see that the right hand side is multiple of 10, right? So right side has multiple of 10, so it implies immediately F must be equal 6. Otherwise, you cannot make it 0 at unit digit 0. So you get this, then you put 6 there, then you simplify it, okay? So you get, then you get what? You get 251, 250, and 20. So you divide by 10, you will get this identity cut, get rid of 10, right? All right, so the question is, what is the next step? Step by step. For the same reason, right? For the same reason, I think I'm going to move C to the, to the, yeah, look at this, right? C contributes to the units digit on the right-hand side. And the left-hand side, the units digit is 2. So those numbers never give you units digit, right? So that means C must be equal to. I'm just trying to solve the equation step by step. Okay, C equals 2. Now, once you put 2 there, then you get both sides, you have to divide by 10. So you will get this identity, yeah, 1000A plus 10B and minus D minus 100E. Okay, so the equations get simpler. And for the same reason, again, okay, so the D is on the left, on right side minus D. Now you can move the D to the right hand side, okay, and clearly D must be 0, okay. So that implies D must be 0 because the left hand side is multiple 10, the right hand side except for D they are multiple 10, so D must be 0. So now D is gone, then both sides divide by 10, right? And now you clear. So you will see from this side, and B should be equal to 5, right? Clear, B is 5. B is 5. And after getting rid of a B, then you have then divide by 10, and then you get something like that, right? Yeah. First of all, you get rid of 5. 20 equals 100A minus 10E, then you divide by 10, then you get this answer, okay? So now it's clear that E must be equal to 8, okay? Then E must be equal to 8, then 10 equals 10A, then implies A equals 1, okay? So you got all the digits through this equation. It's a very, yeah, this is an interesting problem. It's the equation itself, it's pretty long equation, but we figured out one by one. Okay. Okay. Our next problem. Yeah, our next problem is as follows. Okay. A positive 4-digit integers that use each of the 4 digits, 1, 2, 3, 4, exactly ones, are ordered from the least to the greatest. What is a 15th integer in the list? Okay, so right, you have yeah, the positive 4-digit integers, right? that use each of the digits. 1, 2, 3, 4 exactly once. Okay, are ordered in the sequence. Okay, from the list to the you want to find the 15th one. Okay. Find the 15 in the list. Now this is not the equation, just trying to figure it out. Where's the 15th one? Okay. And let's do this. So we list see this so the digits you can list like that. Begin with 1 star star star, right? And from the list, right? Then from 2 to right, and then 3 star star star, and 4 star. Okay. First of all, you have to figure out in which group, right? And the 15th one, right? So here you see that you permitted three digits. You have a total 6 choices, right? 6, right? And also have a 6, have 6 and 6, right? So 12. So the 15th one must be inside of this group, okay? Right? The 15th one must be inside this group. Then you figured out in this group you want to start from the list one, right? Then you look at 3, right? And then you have the list one is 1. You have 3 digits here, only have 3 digits, 1 and 2 and 4. Okay, right? So you just need to get so to already have 12 there, the third one, right? The third one gives you the 15th one. The third one in this group. Okay, so you fix 1, right? Then you have a 1, 2, 4, right? Then you have then the next one is a 1, 3, 1, 4, 2, right? Then you have to change the number, right? 3, 2, 1, 4. Okay, So that will be the next one, you know, from the list to greatest. Okay, that should be the, yeah, that should be the answer. Okay, so in the same group, yeah, this should be the answer in the same group. 1, 2. Yeah, then the fourth one will be 3, 2, 4, 1. Then you, then 3, you know, then 3, 4, 1, 2, then 3, 4, 2, 1. So just in this kind of list, right? Yeah, 3, 2, 4, 1. Okay, so this is from the list to the greatest. Okay, so those are the problems. If you have questions when you do the homework, please give to me day before the class, not to the last minute. Okay.